Alright, so welcome back to Jin Academy. Today we're gonna talk about some useful equations in 2D motion. So let me write down equation. Alright, cool. So talking about equations in 2D motion, there are only a grand total of 4 equations that you really gotta know. Maybe 5. Let's see. So the first equation is actually really easy. It's actually a concept. It's not even like an equation or something. So the first equation is V final. Let's say VF, which is the final velocity, equals no. Oh, sorry, man. Sorry, made a mistake here. It's not V final. It's V average. So V average here, that VAVG. V average equals to V initial plus V final over 2. So what does this even mean? Alright, so let's say this is our velocity function, velocity graph right here. So the velocity is like this. So from here to a straight line. From here to here. Alright, so velocity is like this. So what is the so here clearly this, let me change the color, green. Alright, so this is its initial velocity and this is its final velocity. So what is its average velocity? Clearly you can see is that plus that divided by 2, which is our function right here. So the average line is actually, let me change to another color, red, sort of like this. Because like, right, so like when we know distance x, distance equals to speed multiplied by time, right? But when we're trying to use this equation and then when v is not constant, then we can't use this equation. So what we do is we find the average velocity, which is this v average, and then we plug this way in here, then it'll all work out. Right, so that's not even the equation, that's just a concept. And then yeah, so let's do another one. Let's do another equation. Alright, so the second equation I'm going to tell you is it's a really useful equation. It's called V final equals to V initial, and sometimes it's O is 0 here, like it means when V is at time equals to 0, so it's also the initial velocity. It equals to V initial plus A acceleration T. Let's see, what does this equation mean? So V final, the final velocity, the velocity when the object, like at the end point of like what you're observing, is equal to the initial velocity. So let's see, again, this is our velocity vector, and then our velocity is moving like, say, no, not this. So ignore that. Ignore that. Our velocity is actually moving like this, like this. So let's see, the velocity is not starting from a 0. Where is it starting? It's starting right here. Let's say it's like 1 or something. Let's just say it's 1. It's 1 right here. So the velocity keeps on moving up. So clearly the final velocity right here is better than the initial velocity. That's why you have to plus AT. What is A? A is acceleration. What's acceleration? The factor that the velocity increasing. So just A times T. It gives you this it gives you this, and you add this and that, it gives you final velocity. This is AT, and this is V initial, and then alright, cool. So let's say, so here A is positive. That's why this graph is the velocity is going up. So let's see, what if the velocity is actually let's say, what if the velocity is the acceleration is negative, and the whole entire case is gonna be different. So again, so v final equals to v initial plus a t, and then this is our vector right here. So this is so let's say if v starts from here from 1 again, and then v goes down suddenly like this. So what's gonna happen? All right, so what's gonna happen in this case? In this case, the velocity is decreasing, is moving down. So clearly the acceleration is negative. So that's why you still leave this plus sign here, and you change the acceleration to like a negative value. So the initial velocity is getting lower and lower, lower to the final velocity right here. All right, cool. So that's it for this equation. Let's do another equation. It doesn't really work for you to erase things with sky blue, but I mean, yeah, cool. Because I haven't figured out this paint thing completely yet. So, all right. So let's do another equation. This equation is really important. This is called this is like pretty much all this for two questions is x final, or you say x equals to x initial is x0 plus v initial v0 times t, and plus 1/2 a t squared. Alright, so what does it mean by this equation? Crazy looking equation. I know you guys are like all confusing by this. Like, what does it even mean? Alright, so let's see. I'll demonstrate your question for you guys to understand it. So this is my house right here. A car is departing from my house, so its original distance, which is the position with my house, is x equals 0, and that clearly is initial. All right, so let's say this car starts from rest, start accelerating with a equals to, let's say, 5 meters per second squared, and it starts moving until it moved for like, maybe let's say 10 seconds. So how far is it apart from a house? Let's see. So the x starts off at 0, so x initial is 0. So just don't worry about x initial. And then let's say the v initial. Once v initial, the car starts from rest, so v initial has to be 0. So v initial is 0 also. So v initial t is 0. So don't worry about these. 1/2 a t squared. So what's a? 5 t 10 seconds. So it's just 1/2 times 5 times 10 seconds. So x equals to 1/2 times 5, which is 2.5, times 10 seconds squared, which is 100 seconds, which is 250. So during this 10 seconds, it moved 250 meters. And then I know like you can notice that I don't really write units a lot during my equations, but the thing is for you guys, like you better not leave the units, you know, because like in exams and like for response question they count. So yeah, just be careful on these. Like I have a bad habit. Don't follow me on this. All right, cool. So use these equations. If you use them like back and forth, you can actually like get a lot of things. Like here in this question, I gave you a and t and x initial, v initial. But let's say in another question, what if you know like x final and x initial and v and t and try to get it should be fairly easy, right? All right, so that's it for this class because I already spent 10 minutes. So yeah, I'll see you next time. We still have one equation to talk about. That's it.